Alright, we're going to check out how to do an application problem using some of the trig ratios and some of the practices that we've been using lately. Okay, so check out the problem that we have here. Ian is standing on top of a cliff, and he's looking down at a fox in the valley below. His eye level is at about a height of 1.9 meters above the cliff's height. He looks down at an angle of depression from the horizontal at 50 degrees. The fox is 75 meters away from the base of the cliff. How tall is the cliff? Okay, so whenever you're given a story problem like this, your first job is to just kind of pull apart all of the language and pull out the important parts, okay? And I do that by drawing a diagram. So whenever you do application problems, make sure you draw a diagram or a picture, some kind of sketch. So here I drew a little cliff, and I used, some lovely clip art here to put Ian up on the cliff and put a fox down below in the valley. Okay, then we label things according to the story problem. So it said the fox was 75 meters away from the base of the cliff, so the green line on the base labels that 75 meters. The cliff, we don't know how tall it is, so I put cliff equals question mark. But we know Ian is 1.9 meters from his feet to his eye level, so that's labeled there. The other thing that is a little bit confusing in the way that it's worded is talking about the angle. It says he looks down with an angle of depression from the horizontal at 50 degrees. Okay, angle of depression means going downward. And from the horizontal means, well, think about the horizon, horizontal line. So coming down from a horizontal line, and we have 50 degrees. So this angle is marked 50 degrees. And now we have enough information that we can select what tools we need in order to solve the problem. It's going to be kind of a two-step problem, because first we can solve for how tall it is from the bottom of the cliff all the way up to how tall Ian is. And from there we can subtract his height in order to figure out just the cliff's height. Okay, so we have a right angle. That is where the cliff meets the ground. So knowing that, we can choose from our tools. Either we're going to use Pythagorean theorem, or we're going to use some kind of trig ratio. In this case, we know what one side is and what one angle is, so we can use trig ratios. So I labeled my sides. The side adjacent to 50 degrees happens to be the height of the cliff and the person, so I labeled that adjacent side A, and then directly across from the 50-degree angle is side O, our opposite side. So 75 is O, and our unknown height here is A. So we have an O and an A, so we know we're dealing with tangent because of TOA, TOA. And our next step is to set up an equation that we can solve. So let's take a look at that. So we have the tangent of 50 degrees has to equal the ratio of opposite over adjacent. Okay, opposite over adjacent. Now our x is in the denominator, so we have to look at our cross products in order to get it out of there. Alright, x times tangent of 50 degrees is x times tangent of 50 degrees. 1 times 75 gives us 75. From there we can go ahead and solve. To isolate our variable x, we need to divide both sides by the tangent of 50. Alright, when we do that, anything divided by itself is 1. So then we are just left with x equals 75 divided by the tangent of 50. If you put that in your calculator, then x is approximately, let's see here, it's about 62.93247. After the 2 comes a 4, so I'm just going to round it off. It's not 5 or higher, so it'll stay at 2 there in the thousandths place. So that tells us about how tall it is from the ground all the way up to the top of Ian's head, or at least to his eyesight. So we don't want to include Ian in the height that we're measuring here. We want to find out just how tall the cliff is, so we have to take away his height. So we're going to subtract away the 1.9, and then whatever we're left with is the actual height of the cliff. So then our cliff equals approximately 61.032 meters. Okay, let's see if that makes sense. So we went through, drew a diagram, pulling out important information. We labeled things appropriately. We found out, oh, it's not quite a simple triangle problem. We had an additional height that we had to think about. So we planned on dealing with that in the end, which we did. We subtracted his height away in the end. And we used our trig ratios in order to solve it. And that's about it.